following has been developed by state and provincial agencies in association with the Agency for Instructional Technology. Together, serving education.
Just as many or more girls participating in school sports as boys, and sometimes many more in intramural sports. For example, there are 26 girls playing intramural volleyball and only 12 boys. Baseball, 44 girls, 18 boys. Soccer, 35 girls, 42 boys.
What was that again? 44 girls for volleyball.
No, that was baseball. 26 for volleyball.
And how many boys again?
12 boys for volleyball and 18 for baseball.
But Mr. Keenan, the point is, girls participate in just as many sports, win just as many or maybe more trophies, and we still don't have decent uniforms.
I don't know about that. Our boys won the soccer league, what was it, 2 years ago?
But this year the girls were league swimming and gymnastic champs and came close in volleyball.
That may be true. But it seems to me the boys earn more of the money for their uniforms through their fundraisers. Isn't that not so?
No, I've got the figures here. Somewhere.
Listen, girls, I appreciate your efforts. Unfortunately, I have another meeting in a few minutes. We'll talk again sometime. I'm sorry.
We blew it.
It's so frustrating. We have the proof.
Yeah.
It's just so disorganized.
Yeah.
We've got to show him. Somehow.
Yeah.
First human walked on.
A group of private businessmen made an impressive presentation for a Dome Stadium today at City Hall. Their research showed that a full 23% of the population is most interested in attending sporting functions as their primary source of entertainment. The mayor said he was very impressed with the convincing presentation, and the council went on to approve the Dome proposal by a large margin. In other news, the city council approved two contracts.
Graphs are useful for conveying information clearly, concisely, and in a concrete way. In fact, we say something is graphically illustrated when it has been clearly described. Different kinds of graphs convey different kinds of information. The circle graph, for instance, shows the proportions of each part to the whole. For example, 23% out of 100% of all people in this city would rather watch a sports attraction than any other type of entertainment. You'll notice that the percentages always add up to 100%. Watch for the characteristics of the other graphs that we'll be seeing.
I'm sure it'll work. We've got all the facts, but they're all disorganized and hard to understand. I'm sure if we put them in graphs, he'll be convinced.
Okay, how do we start?
Well, we've got to show that girls are participating as much as boys in all kinds of sports.
And that we win as many trophies.
And that we deserve new uniforms as much as the boys.
More!
Right, more than the boys. And so we deserve as much of the budget for our uniforms.
Right.
So?
Yeah.
Well?
I don't know.
Let me think.
Let's start with the circle graph. See if we can do something with it.
Okay.
Okay, the circle is everybody in the school.
Except the teachers.
Right.
And the gerbils.
Right. There are 300 students. 100 girls participate, which is 1/3 of the student body. So draw a third of the circle.
The good guys.
Now let's be fair. Label it girl participants.
And the bad guys.
75 boys participate, or 1/4 of the student body. Boy participants.
And then there's the rest.
Right, non-participants. pretty convincing, and we can color the pieces of pie to make it even clearer.
Pink and blue?
It'd be clear at least.
Okay, but remember, you asked for it.
It's okay, but we need more.
Like, how do we show that there are hardly any boys playing volleyball? Sure, they play soccer, but what else do they do?
Yeah.
If we used a circle graph, we could try to compare the boys' and the girls' participation. No, wait, that's not right. We need a graph which can show comparisons of two things at a time really well.
What about the bar graph? I think the bar graph will work really well for that. Like this. One for baseball. Boys and girls. One for soccer. Boys and girls. And one for volleyball. Boys and girls.
That should do the trick.
I think our ace in the hole will be the line graph, though. See? I've done a rough draft.
Why do we need a line graph?
Because we can show clearly how things have changed over a period of time. We want to show how fast girl sports have developed over the last 20 years. My mom was saying how seldom girls used to participate in sports when she was at school, so I looked it up and found the figures. Got them right here. I think this will really nail it down for us.
Okay, let's get graphing.
The girls are designing the three main types of graphs. But how did they decide which graph to use for which purpose? Would it have been possible for them to choose a line graph instead of the circle graph to present their percentage information? Yes, but it wouldn't have shown the information as well. The line graph worked really well for showing how things related over a period of time. Whereas the circle graph shows what proportion of the whole each part forms. The bar graph, on the other hand, shows best how two sets of data relate to each other. Deciding which graph to use in which situation is often vital to clear communication.
My name is Elizabeth Novickis. I'm the graphics editor for the State Journal Register in Springfield, Illinois. Part of my job here involves creating graphs and charts for the newspaper. We like to use graphs to express relationships between numbers because it's very difficult for a person looking at, say, for instance, a list of numbers to grasp the relationship between each and every one of them. When we present those numbers in visual terms, they're recognizable at a glance. The business editor brings me a story that he would like to see illustrated. The story is about a company, PepsiCo, that has been going through some changes. In this case, we're going to look at how the sales have been, how their income has been, and also how the various segments of PepsiCo have been doing. I start out by doing a very rough sketch, small sketch on a pad of paper, which gives me a general impression of what the trends have been. I've determined that I want to do the sales and the income as line charts. I also want to do a pie chart showing how the sales from the different segments have performed in the last year. We'd like to incorporate some artwork with these charts to liven it up a little bit. I'll be looking through the company's annual report, and in this case I spy a picture of a person holding a can of Pepsi, and it occurs to me that the can will be a nice surface in which to insert the pie chart. As I'm working up this artwork, I have to do the pie chart by hand, use a protractor to make all the measurements. However, our computer here is set up so that it can draw the line charts for me. So all I have to do when I'm arranging my artwork here is to simply leave a space for where that line chart is going to go. Later, when I'm done with this sketch, I will go to the computer terminal, sit down, and plug in the numbers that I need here. On the Xerox copy, I'll color in the logo in its proper colors, red and blue, and then I may use some red on the charts and a little bit of blue on the sleeve of the hand. I'll then color the background in yellow, and the hand, of course, in a flesh tone. The color sketch helps me determine how the finished artwork will look. At this point, I have to make an overlay for each of the different colors I'm using. There's an overlay for the blue, the red, the flesh tone, and the yellow. The artwork is then sent down to engraving. Engraving will make negatives, which will then be exposed onto metal plates, which is what we use on a printing press to create the black and all the different colors that go into this chart. The reason why I really enjoy this career is because it allows me to combine interest in math as well as an interest in art. And I'm also working on a newspaper, which is a very exciting sort of field to be in.
Our first graph will show the proportion of girl participants to boy participants and non-participants. Girl participants are in pink, boy participants are in blue, and non-participants are in orange.
Very impressive. Quite a few more girl participants. But what worries me is that orange area.
The bloated blob of society.
Now our second graph, the bar graph, will give you a quick visual comparison of the participation levels in all sports. As you can see, except for soccer, in every other sport, more girls participate than boys.
I didn't realize that, but I guess I'm just showing my age and my bias. Because when I went to school, girls didn't participate as much.
That's right. I found some figures from the last 20 years, and we put them into a graph, the line graph. As you can see, 20 years ago, boys were far ahead of girls in participation, but while their level of participation has remained relatively even, girls' participation has grown by leaps and bounds.
And here is another graph, a circle graph, to illustrate the number of trophies won by the girls as compared with the number won by the boys over the last 5 years.
And yet, in this last graph, although we have won more trophies, participate more, and have grown more rapidly over the last 20 years, the amount of the pie which is given to girls' uniforms is almost too small to see on this circle graph. And that all adds up to 100%.
You're right. That seems very clear to me now. And I agree, it's not fair. I'll bring it up at the next board meeting, and I think I'll take your graphs with me to prove the point. I think you girls will have new uniforms before the year is out.
Thanks, Mr. Keenan.
You really did show me something.
On the field and on the graphs, right?
Right.
So remember, when you're trying to prove something using numbers and someone says, "Show me," see if a graph can do the trick. It's a clear, concise way of conveying information. The circle graph for parts of a whole, the bar graph to make quick visual comparisons between sets of data, and the line graph to show development over a period of time. Use graphs whenever you want to illustrate something forcefully. To prove your point, be graphic.
MathWorks is a component of the Mathematics for the 80s project and is supported in part by Exxon Education Foundation.
This program was produced by the Illinois State Board of Education under the supervision of the Agency for Instructional Technology.